All right, moving along now to example number 5 here. And this is going to be very similar to what we did in last example in that we're going to use the power rule. However, this one now has a double radical. And when we have two radicals, that means double the work, or in another case, we're going to have to square twice. Okay, so I'm going to show you how this works here. This work is going to get a little long, so you may need to pause the video and catch up there, and then you need to rewind things here because this is going to get a tad bit lengthy here. Okay, so first of all, let's just go over one rule real quick that we're going to use a couple of times to kind of speed things up just a tad bit. If I said what's x minus y squared, okay, let's just go ahead and set up a rule for that. Okay, so x minus y squared means x minus y times x minus y. Okay, so I'm using variables, so that means whenever we get our result, we can use that for any number then. So when I use FOIL, okay, I'm going to go ahead and do x times x, okay, and that's going to give us x squared. Okay, so right here, this will give us x squared. And then x times negative y is a negative xy. And then negative y times x is another negative xy. And then negative y times negative y is a positive y squared. So as you can see here, these two guys we can add together because there's a negative 1xy, a negative 1xy. So we'll get x squared minus 2xy because there are two of them. There's one right here, one right here. So 1, 1 because there's two of them, plus y squared. Okay, so I show that to you so that x minus y squared, what you do is you square the first term, you take the x and the y term and you multiply them by -2, and then you take the y term and then you square it. So this is just kind of like just a tad bit shorter way instead of doing the whole FOIL method, and we're going to use this twice in our problem here. Okay. All right, so first of all, let's go ahead and first isolate one of our radicals. Okay, so I'm going to get this guy all by itself right here. All right, so I'm going to go ahead and subtract radical x plus 1 from both sides, okay? So those guys are gone, and I'll get radical 2x plus 3 is equal to 1 minus the square root of x plus 1. Okay, so first step right there, I just subtracted radical x plus 1. So now that our radical is isolated, we can go ahead and square both sides, okay, because we want to get rid of this radical here. So I'm going to square the left side, and I'm going to do the same thing to the right. I'm going to square the right side. So squaring a square root eliminates the radical, so those are gone. So I get 2x plus 3. Now what about this guy? Okay, so check out this dude. Doesn't this guy right here, this right here means 1 minus radical x plus 1 times 1 minus radical x plus 1, right? This means this, okay? And this looks just like the rule that we just kind of came up with right now, meaning if I have an x minus y squared like this is my x and this is my y. Okay, I'll go ahead and label that. So this is like my x and this is like my y. If I do x minus y squared, the rule is just this. I take the first term, x, and I square it, minus 2 times xy. I'm going to multiply those guys together, and then plus y squared. So I'm going to go ahead and do that now. I'm going to take my first term, 1, and I'm going to square it. So 1 squared is just 1. I'm going to do -2, and then I'm going to multiply x times y. Well, x is 1 and y is negative radical x plus 1. So I'm just going to put right here radical x plus 1. Okay. And then lastly, it's going to be plus y squared. So it's plus, and then I square this. Well, if I square a square root, doesn't the radical go away? Well, yeah, right? So that means we get x plus 1. Okay. Now, if that was like, I don't know about that, dude, you can actually go ahead and use the FOIL method and do the first term, do the second term, and then do the inside term, and then do the last. So basically, this is just kind of expediting the process. It is a tad bit nerdy, but this is the way that you would get this right here. Okay. Now, we can clean this up just a tad bit here, right? Can't we add together the 1 and the 1 right here? I could just go ahead and combine those guys together. So let's go ahead and do that. So 2x plus 3 equals, I'm gonna go ahead and add 1 and 1 together. So I'm gonna get 2, and then I have my x right here plus x, and then I have my minus radical, or minus 2 times radical x plus 1. All right? So, what you want to do next now, I know you're like, dude, what the heck? Where are we going with this? This guy's hairy. Well, let's go ahead and move the 2 over, and let's move the x over there. So that means we're going to isolate the radical again. So I'm going to subtract 2 from both sides, and then I'm going to subtract x from both sides. So I'm kind of doing 2 steps there all in one. So that means we will get 2x minus x is just x. 3 minus 2 is positive 1. And then we're left with just this guy, because those guys are gone. Negative 2 radical x plus 1. Okay. We're not done yet. We're like halfway. You're like, no. That's right. We're only halfway done. So don't put your pencil down. If you have to go put, pause in and go get a drink real quick or something, I don't know though, but okay, come back. Here we go. So basically, we're going to go back and do step 1 again. Wasn't step 1 to first isolate the radical and then square both sides? It's kind of we're doing the problem all over again. That's what we're going to do. We're going to go ahead and square both sides now. All right. So I'm going to square the left side. And again, the purpose of squaring both sides is to eliminate the radical. Okay, that's the only way that we're going to solve these guys is by squaring them so that the radicals eliminate. So x plus 1 squared, okay. Again, we can use the cool shortcut. If I have x plus y squared, that's the same thing as x squared plus 2xy plus y squared. And then the other one, again, is if you have a minus sign, it's x squared minus 2xy plus y squared. So we're going to use this shortcut right here. Or if you want, you could do the FOIL. Okay, you can FOIL this out. All right. So x plus 1 squared. This is my x. This is my y. So I'm going to take the first term and square it. So this becomes x squared plus 2 times x times y. So plus 2 and then x times y. Well, isn't that just x times 1, which is x? And then plus y squared, or 1 squared. So 1. Cool. So that's what the left side is. Okay. So if you wanted to do the work, x plus 1 times x plus 1, you could do the FOIL method, and you're going to get x squared plus 2x plus 1. Or the little bit of a shortcut is to use this guy. Equals. Now watch this now. So this right here means I square the negative 2 and I square this guy. Okay. If it had a plus sign or a minus sign, then you couldn't just square each term, right? You have to use either one of these shortcuts. But since it's being multiplied, I square this and I square that. So negative 2 squared gives us our quattro. And then the square root of x plus 1 squared is just x plus 1. But notice how I put that in parentheses because we're actually multiplying negative 2 times this. So it has to still stay as a product. Okay, it's all downhill now. So let's go ahead and multiply these guys out. And then we can go ahead and put everything on the left-hand side. So we have x squared plus 2x plus 1 equals 4 times x is 4x. And then 4 times 1 is plus 4. Now let's go ahead and move the 4x and move the 4 to the left side. So I'm going to subtract 4x, and I'm also going to do minus 4, minus 4. So x squared minus 2x, and then that's going to become, okay, and that becomes minus 3. Oops, my pen little thing went away. Minus 3 equals 0. Okay, so now we want to go ahead and factor this. And we could use my cool little judo x. And put the negative 3 on top. And I put the negative 2 on the bottom. So two numbers that multiply and give me negative 3 and add to get negative 2. So let's see. It's going to be a negative 3 and 1, right? Negative 3 times 1. Oh, that's my bell right there. Negative 3 times 1 is negative 3, and negative 3 plus 1 is negative 2. Okay, so those are my two factors, x minus 3 and x minus 1. Oops, x plus 1 equals 0. So now I set each term equal to 0. So x minus 3 equals 0, and x plus 1 equals 0. Now I solve for x, so I'm going to add 3 to both sides. X equals 3. And I'm going to subtract 1 to both sides, so x equals negative 1. Okay, so yeah, that was a little bit of a short problem, yeah? And if that's not enough, we still have to check our answers, right? Because we can have an answer that's actually not part of our solution. So we have to check your answer. Check your answer. So let's write the original problem again. The original problem was the square root of 2x plus 3 is equal to 1 minus the square root of x plus 1. Okay, so let's check by first plugging in 3. All right? So if I plug in 3, that's radical 2 times 3 plus 3. Is that equal to 1 minus radical 3 plus 1? Well, let's see here. 2 and 3 right here is going to give us 6 plus 3. So that's going to give us 9 right there. Square root of 9. And this is 1 minus x plus 1, or 3 plus 1 is 4. So that's going to be 3. 1 minus the square root of 4 is 2. So 3 is not equal to negative 1, which means that we can eliminate the answer x equals 3. It's not part of the solution. We plugged it back in, and we got a false answer. Now let's go ahead and check negative 1. So I'm going to go and replace all the x's with negative 1. So let's see here. 2 times negative 1 plus 3. And is that equal to 1 minus the square root of negative 1 plus 1? Let's see. 2 times negative 1 is negative 2. Negative 2 plus 3 is just a positive 1. And let's see, this right here is 1. Negative 1 plus 1 is 0. So 1 minus 0, because the square root of 0 is just 0. So the square root of 1 is 1 equals 1. Dang. And there it is. So we can now say that 3 is not an answer and negative 1 is an answer. Alrighty.